We are continuing some of the important terms in coordination chemistry 1. The next important term is ligand. So ligand is also another important moiety in coordination complex. So you understood metal which accept pair of electron from the ligand, and that's why the metal is called as Lewis acid. In the same way, so the ligands are either anions or neutral molecules. So these are donate a pair of electron to the central metal atom to form coordination bond. So the property of a ligand to donate pair of electron to the central metal ion. So that's why this is called as Lewis base. So next, coordination number. The coordination number is nothing but is the number of central metal atom in which the number of coordination bond, single coordination bond which is present around the central metal ion, it is nothing but coordination number. Or we can also define as the number of electron pair donor which is present around the central metal ion. So this is called as coordination number. Next, coordination sphere. The non-ionizable part of a complex compound which consists central metal ion surrounded by ligand which is enclosed by a square bracket. So this is called as coordination sphere. Just in the previous slide I showed one diagram of coordination complex. In that you found metal and ligand, these are enclosed in a square bracket. That part is called as coordination sphere. Excluding that, the thing which is outside the square bracket which is called as ionization sphere, and that ion is called as counter ion. And coordination polyhedron, that means the myriad number of ligand surrounds central metal atom and they are occupied a suitable position in a space and they form a proper geometry. So this is called as coordination polyhedron. Next, type of coordination complex. So based on the charge, based on the type of ligand which is attached to the central metal atom, so these coordination complexes are classified in 6 ways. So the first one is cationic complexes. So you just look at the complexes. So this is hexa-amino cobalt complexes. Here, so the chloride ion, the charge is Cl minus. So this is the charge of this counter ion, and the charge of the complex is positive. If the charge of the complex or not complex coordination sphere is positive, then it is called as cationic complex. And similarly anionic complex. Here if you look at the complex, so hexa methyl iron complex. Here, so potassium positive and so this is negative. If the coordination sphere possesses negative charge, so this is anionic complex. And neutral complex, you just look at the compound. So here, so there is no charge on this square bracket. So this is neutral complex. Here both ligand nickel and central metal ion nickel and ligand carbonyl CO both are neutral. That's why it is neutral complex. And homoleptic complex. So here you just look at the complex. It is contain only one type of ligand. So the complex consists of similar type of ligand is called as homoleptic complex. And heteroleptic complex. Suppose if the coordination complex contain a different types of ligand, for example here chlorine, amine, two different ligands are there. That's why it is called as heteroleptic ligands. And mononuclear ligands, that means in these ligands, so sometimes this mononuclear polynuclear classification is based on the nature and number of different types of metal which is present in the coordination sphere. So we studied only one type of coordination one type of central metal ion which is present in a coordination sphere. Sometimes more than two different coordinate central metal ion is present in a coordination sphere. So based on that, we are classified into mononuclear and polynuclear coordination complex. Here, in any coordination complex, the central metal ion which is present in the center. Okay, so in mononuclear only iron is present, but if you take polynuclear, so more than one central metal ion that I am going to discuss little bit later. So these are the 6 type of complexes based on the charge, based on the ligands, based on the central metal ion. We are classifying the coordination complexes into 6 types. Next, classification of ligand. This is very important. The first classification based on the charge. Based on the charge, there are 3 types of complexes. So one is 3 kinds of ligands. So negative ligand, positive ligand and neutral ligand. So, ligand means these are the species that donate electron to the central metal atom. So obviously what we are going to think here is any species which is giving electron means it must be electrically rich. Okay, it must be negative or it has some lone pair electron. But here some positive ions are also act as ligands, nitrocilium and hydrazinium ion. Here because of here donor atom is nitrogen. If you consider ligand, okay, as I told, ligand is an atom or molecule. So for example, chloride, okay, so chlorine, this is atom, single entity, but here Cn molecule, okay. If you consider atom, chlorine act as donor atom, ligand donate electron. In that ligand, one of the particular atom donates electron. The particular atom which is going to donate the electron to form a covalent bond, coordination bond. So this is called as donor atom. So if you take a molecular ligand, so here carbon and nitrogens are there. Here not both act as donor atom. Here nitrogen act as donor atom. Sometimes both are act as donor atom, that I will discuss later. So this is negative ligand, and in this case the nitrogen is donor atom here because of lone pair electron. Okay, so it donates electron. And similarly here also hydrazinium. Okay, these lone pair electrons are responsible for liganding nature of this positive molecule. And neutral, carbon monoxide, ammonia, water, ammonium hydroxide, methylenamine. These are neutral ligands. Next classification is based on the number of electron pair donated by the ligands. That means sometimes a ligand can donate 1 pair of electron. If any ligand donate 1 pair of electron, it form 1 bond. It form a single coordination bond. Suppose if a ligand donate 2 pair of electron, it form 2 bonds. Suppose if it is donate 3 electron, it form 3 covalent bond. It is not triple bond. So it is a 3 separate coordination bond. So based on the number of electron donated by the ligands are classified as follows. The first one is monodentate ligand, bidentate ligand, polydentate ligand. So again, ambidentate ligand, chelating ligand. So again, polydentate ligands are classified as tridentate, tetradentate, pentadentate and hexadentate ligand. So let us see one by one. Unidentate ligand. So monodentate ligand also called as unidentate ligand. So this monodentate ligand donate only 1 pair of electron, or the monodentate ligands of the ligand, they form only 1 single coordination bond with the central metal atom. So these are called as monodentate ligands. So the best examples are amine, chloride, bromide, carbonyl, carbon monoxide, water. So these are all monodentate ligand. Next, bidentate ligand. These ligands donate two pair of electrons. So and they form two single covalent bond with the central metal ion. That's why these are called as bidentate ligand. The best example for bidentate ligand is 1,2-diaminoethane and ethane diode ion. So you just look at here the first example. Another example is oxalate, carbonate, and dimethyl glycine. These are all example of bidentate ligand. So we can understand by taking ethane 1,2-diamine. You just observe this T compound NH2 CH2 CH2 NH2. This is also called as ethane 1,2-diamine or 1,2-diaminoethane. Here in the terminal position it has two NH2 group. In 2 NH2 group, the two dots which is nearby nitrogen, that is here. So 2 nitrogen are act as donor atom, that is the 2 nitrogen. Each nitrogen donate one pair of electron and they form one single coordination bond each. So totally there are 2 coordination bond formed by one molecule. That's why this is called as bidentate ligand. Next, polydentate ligand. So the ligand which can form more than 2 coordination bond with central metal ion, this is called as polydentate ligand. So again polydentate ligand are further classified as tetra, tri, tetra, penta and hexadentate ligand. So this is a tridentate ligand. You just observe here in this ligand 3 amino groups are there. 3 amino groups. There are in each the nitrogen atom act as donor atom. So totally there are 3 nitrogen atoms. There are 3 donor atoms. That's why it form 3 covalent bond. That's why it is called as tridentate ligand. And just look at another example. So the name of the compound is diethyl. See, CH2 CH2 1 ethyl, CH2 CH2 1 ethyl, diethyl triamine. So this is an example for tridentate ligand. Next, another example, another type of ligand is tetradentate ligand. That means it can form 4 coordination bond with a central metal atom. Here the 4 coordination bond are formed by the 4 donor nitrogen atom. You just look at the molecule here. So it has 4 donor nitrogen. So each one form one single coordination bond. So totally it can form 4 coordination bond. So totally donate 4 pair of electron to the central metal atom. That's why it is called as tetradentate ligand, and the name of the molecule is triethylene tetramine. So triene. So this is called as ene. In short way we are going to represent as ene. So this is triene. Next, hexadentate ligand. Hexadentate ligand means this ligand can donate 6 pair of electron or it forms 6 bond. The best example is EDTA. I think if you have used this EDTA in the titration, in the estimation of zinc, magnesium, hardness, if you have used this sodium EDTA in the laboratory. So this ethylene diamine tetraacetate is best example for hexadentate ligand. Here just you look at here the 4 atoms, 4 oxygen atom which is present on the 4 corners of this molecule and 2 nitrogen which is indicated in the blue line. These are totally there are 6 donor atom which is present in this molecule. That's why it forms 6 coordination bond with the central metal ion.